Alright, so this is the last section that I'll do a video on for Chapter 2. In each chapter that we do, there's two sections that kind of tag along at the end of each chapter. One section's called the Chapter 2 Review, and it is a review of everything that we cover in the chapter, and absolutely guaranteed if you can do every problem on the review for a particular chapter, then you can do every problem on the test. The next section after the Chapter 2 review is going to be called the Chapter 2 practice test. And that there won't be a video for. And it's another tool to help you study for the test. The Chapter 2 practice test I complete in class. And normally, if you can do every problem on the practice test, you should be able to do every problem on the test. Generally, the practice test is kind of exactly like the in-class test in terms of the number and kinds of questions, just the questions on the in-class test might be in a different order. Occasionally, there might be one problem on the in-class test that doesn't show up on the practice test. So every single problem on a practice test is generally guaranteed to come up on the test, but there might be one extra problem that is on the test that isn't on the practice test. Whereas the Chapter 2 review, or the chapter review, will cover anything that could possibly be on the test. The chapter review is a little bit longer than the practice test, and if you can do every problem on the review, then you'll be able to do every problem on the test. If you could do every problem on the practice test, there might be one problem that comes up on the test that's on the review that's not on the practice test. So if you want to be completely safe when you're studying for the test, make sure you can do every problem on the review for each individual chapter. There are certainly problems that come up in the chapter that don't make it onto the review. Any problem that's in the body of the chapter that doesn't have kind of a brother problem on the chapter review won't be on the test. So when you're studying for the test, you should study the chapter review if you've got lots of time to study. If time gets to be an issue and getting an A isn't the biggest deal to you, focusing on the practice test will at least get you enough to get a B and very likely an A. But again, the practice test I complete in class, it might be a little bit shorter than the test. The review is definitely longer than the test. There'll never be anything on the test that's not like something on the review. So now I need to just go through the review. I do all of the problems, even and odds, when I do the review. So problems 1 through 6 ask me to find the X and the Y-intercepts. So the instructions tell me what to do. Without the instructions, I wouldn't know what to do with this. It doesn't say anything about graphing, so I'm not going to worry about graphing. I'm just going to find my intercepts. And to find an X intercept, or intercepts if there happen to be two, I plug 0 in for Y and solve for X. To find a Y-intercept, or intercepts if there happen to be two, I let X equal to 0 and solve for Y. Because these are points on the graph, when I go to write my answer, I'm going to write them as points. Which means I need an X and a Y, and always the opposite letter position is a 0. And I'll get to that in a second. I'm just kind of setting up the body of what I'm going to do. So first I'm going to find the X-intercept. I'm just going to plug 0 in for Y. This you can conceivably do in your head. It's not that impressive to do this in your head. And if you show a little bit less work than me on the test but get the same answer, I'm completely good with that. So I plug 0 in for Y. This piece is going to 0 out. It's going to be 4x minus 0, and it's going to turn into 4x. And then I'll divide by 4 and get x equal to 3. And the x-intercept, the x-coordinate's going to be 3. Always when I'm finding an x-intercept, the opposite letter, in this case y, is going to have a 0 for its coordinate. So when I go to write my answer, For the x-intercept, I'm going to write it as the point 3, 0. The x value is 3 for that point. The y value is 0. The second part of this, finding the y-intercept, wants me to plug 0 in for x. So I'm going to go 4 times 0 minus 6y equals to 12. This piece turns out to be 0, and this gives me minus 6y equals to 12. And that'll divide both sides by negative 6. And that'll give me y on the left side, negative 2 on the right side. That's going to go into my answer for the y-intercept, and I can see it as a point. I have x for 0, y for negative 2. So I'm going to enter this as the point 0, negative 2 for my answer. That's the best we could do for number 1. There's no need to graph this because I wasn't asked to graph, and it just takes time that I don't need to spend. When I go to find the x and the y-intercepts for problem 2, I'll have to be careful if I use the square root method to find one of the intercepts, because you need to throw in a plus or minus when you do that. So the first intercept I'm going to find is the x-intercept. I find x-intercepts by letting x equal to 0, letting y equal to 0. So for the x-intercept, I'd go 0 squared equals x plus 49. That would give me 0 equals x plus 49. And then I just minus 49 from both sides. And that will give me minus 49 equal to x. And that's going to be part of my answer. That's the easy part of the answer to problem 2. So the x-intercept is going to be a point, so it needs both a x and a y coordinate. The x coordinate is negative 49. And the y coordinate is 0. When I go to find the y-intercept, I let x be 0. And this is where I have to be careful if I want to solve with square roots. There's going to be 2 ways to solve for the y-intercept. Both of them involve putting in 0 for x. And then once you put 0 in for x, there's the 2 ways you can solve. You can solve by factoring, or you can solve by square roots. I'll solve this by factoring because it's the safer way to solve, because you won't miss a solution if you solve by factoring. To solve the y-intercept by factoring, I need to get the problem set equal to 0. So I'm going to minus 49 from both sides. That will give me y squared minus 49 on the left side and 0 on the right side. Then I'll factor this. This factors into y plus 7 times y minus 7 equals to 0. Now that I have it factored, I'll set each of the factors equal to 0. I'll go y plus 7 equal to 0, y minus 7 equal to 0. For the y plus 7 equal to 0, you can minus 7 from both sides and get y equal to minus 7. For the y minus 7 equal to 0, you can plus 7 from both sides and get y equal to 7. There's going to be 2 individual y-intercepts. The y-coordinates of the y-intercepts are going to be negative and positive 7. The x-coordinate is going to be 0. So when I go to write my answer to problem 2, there's going to be 2 y-intercepts. I'm going to write them as the point 0, negative 7 and 0, 7. The alternate way to find the y-intercepts, when I got to this point, I could have find the y-intercepts or found the y-intercepts by the square root method. And this is the quicker way to find the y-intercepts. Once you had y squared equal to 49, you could have solved with square roots. But you have to be careful. When you introduce a square root into a problem that doesn't start off with a square root, you have to put a plus or minus on one of the square root symbols. So if I was to solve this y-intercept by square rooting, I'd square root the y squared side. Square rooting cancels out a square, and it would leave the y squared side down to a y. And on the right side, the plus or minus symbol would stay, and the square root of 49 is 7. This is saying that the non-zero part of the y-intercepts is 7 and negative 7. So if you want to use the square root strategy to find an intercept, it's completely fine, but just make sure to do a plus or minus. All right, number 3 is messy. Number 3, one of the intercepts I'm either going to have to factor or use the quadratic formula. Let me get into that here in a second. So first I'm going to find the x-intercept. It doesn't matter which intercept you do first. I'm going to let y equal to 0 to find the x-intercept. So I'm going to go 0 equals 2x squared plus 13x minus 7. You have your choices of factoring or using the quadratic formula. And I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, just because most students don't like to factor when there's a number in front of the x squared. So in this particular problem, the a is the number in front of the x squared, which is 2. The b is the number in front of the x to the first power, which is 13. The c is the number without the letter, which is negative 7. So I'm going to write x equals, make my fraction that has a plus or minus sign and a square root symbol. I write a negative sign from the formula and then 13 for the b. Since the b is not negative, it doesn't have to go in a parentheses. Under the radical, I get b squared, which may or may not be in a parentheses. It's just up to you. You don't need a parentheses there. And then minus 4, and then times a, which is 2, times c, which is negative 7, all over 2a, which is 2 times 2. I'll pull out my calculator to do this 13 squared. So I'm going to go 13 squared minus 4 times 2 times negative 7. And under the radical, I get 225. So this comes out to be the square root of 225. I'll do that real quickly. Second square root of 225. Square root of 225 is 15. So when I go to do the quadratic formula, I'm going to get x equals negative 13. The plus or minus sign is going to hang out for a little bit. And this whole piece is going to turn into a 15 because it comes out to the square root of 225, which is 15. The denominator comes out to be 4. Now I'm going to separate this into two problems, one with a plus, one with a minus. I'm going to do 13 plus 15 over 4, and x equals 13 minus 15 over 4. And I'm going to get two x-intercepts. This one comes out to be positive 2 over 4, which is 1/2. This one comes out to be negative 13 and negative 15 are negative 28. It comes out to negative 28 over 4, which is negative 7. So when I go to write my answer, I'm going to squeeze them up here because I want to save some room down low for my y-intercept computation. The x-intercepts, there's going to be two of them. They're going to be the point 1/2, comma 0, and the point negative 7, comma 0. If you wanted to, you could have factored this. This thing's going to factor into x plus 7 times 2x minus 1. And if you factored it, you could have factored it and said x plus 7 equal to 0. That would give me x equal to minus 7. And 2x minus 1 equal to 0 would give me x equal to 1/2. You're more than welcome to solve that by factoring. I won't take the time to show you how to factor that. But if you want to learn how to factor that, I can come to my office and I'll show you. The y-intercept part of this is easier. The y-intercept, I plug 0 in for x, and I go y equals 2 times 0 squared plus 13 times 0 minus 7. This is going to be 2 times 0, which is 0. This is 13 times 0, which is 0. And that leaves me with 0 plus 0 minus 7. And that comes out to minus 7. So in my answer for the y-intercept, the x is going to be 0, the y is going to be negative 7. That's going to be the point 0, negative 7. All right, that's a monstrous problem. We move on to number 4, which is finding the x and the y-intercepts of a fraction. Both 4 and 5 are that. So for 4, to do the x-intercept, I let y equal to 0. So I'm going to go 0 equals x minus 3 over 3x plus 6. And when we did this in the video, I made this something I could solve by cross multiplying. So I wrote the 0 as a fraction. with a 1 in the denominator, because 0 and 0 over 1 are equal to each other, and setting it up to solve this way makes it so I can solve by cross multiplying. So I'm going to cross multiply up and get 1 times x minus 3. I'm going to cross multiply down and get 0 times 3x plus 6. 1 times x minus 3 is just x minus 3. 0 times 3x plus 6 is just 0. And now I need to get the x isolated. There's no square, so I don't need to worry about factoring nor the quadratic formula. I'm just going to add 3 to both sides and get x equal to 3. So part of my answer to number 4, the x-intercept, is the point 3, 0. Next thing I'm going to do is figure out the y-intercept. To find the y-intercept, I let x be 0. So I'm going to go y equals 0 minus 3 over 3 times 0 plus 6, taking those two x's and plugging 0 in. The numerator, 0 minus 3, is minus 3. The denominator comes out to be 0 plus 6, which is 6, and that fraction reduces to negative 1/2. So for the y-intercept, I'm going to put 0 for x and negative 1/2 for y. Alright, 5 is another find the x and the y-intercept, and it's another fraction, so I'll do the same sort of strategy. So for 5, for my x-intercept, I let y equal to 0. This gives me 0 equals x squared minus 5x minus 6 over x plus 1. I'm going to set it up to solve by cross multiplying, so I'm going to write the 0 as a fraction. I'm going to write it 0 over 1 equals x squared minus 5x minus 6 over x plus 1. And I'm going to cross multiply up, and I'm going to cross multiply down. When I cross multiply up, I get 1 times x squared minus 5x minus 6. When I cross multiply down, I get 0 times x plus 1. This part right here, anything times 1 is itself, so you get x squared minus 5x minus 6. On the right side, 0 times anything is that is 0. Now, because I have a square on the left side, I need to solve by factoring. This is a tricky factoring. My lasts have to multiply to 6 and subtract to 5, and they're going to be 1 and 6, because 1 times 6 is 6, and 1 minus 6 is negative 5. Now that I have it factored, I'd go x plus 1 equal to 0, x minus 6 equal to 0. For this one, I'd minus 1 from both sides and get x equal to minus 1. For this one, I'll add 6 to both sides and get x equal to 6. So part of my answer to number 5, the x-intercepts are the point negative 1, 0 and positive 6, 0. I need to figure out the y-intercepts, and for the y-intercept, I let x equal to 0. Lots of zeros to plug in. I'll go y equals to 0 squared minus 5 times 0 minus 6 over 0 plus 1. These two pieces in the numerator come out to be 0, so you get 0 minus 6. The numerator is going to come out to be minus 6. And in the denominator, 0 plus 1 is 1. I'm left with negative 6 over 1, and that fraction reduces to negative 6. So the y-intercept, the y part's going to be negative 6. The x part's going to be 0. So for the y-intercept, I'm going to say it's the point 0, negative 6. All right, one more x and y-intercept problem. So there's 29 problems on the review. I'll probably have to do it in 2 halves. So for number 6, to find the x-intercept, I'm going to let y equal to 0 and go x squared plus 0 squared equals 121. This is going to give me x squared equals 121. Just like before when I had a problem that's set up like this, I can solve by factoring or I can solve by square rooting. If I solve by square rooting, which is the easier way, I have to make sure to put a plus or minus around the side without the x. Square rooting the x squared on the left side gives me x. Square rooting the 121 on the right side gives me 11. So my x-intercepts in my answer are going to be plus or minus 11, means there's two x-intercepts, and I need to write them as points, and my x-intercepts have 0 for the y-coordinate. So I'm going to write the point positive 11, 0, and negative 11, 0 as my x-intercept. And then for the y-intercept, I'm going to plug in 0 for x. It's the same deal here. I'm going to go 0 squared plus y squared equals 121. The 0 squared cancel. That takes me down to y squared equals 121. A lot easier to solve by square rooting. So I'm going to square root plus or minus square root. When I do that, on the left side, the y squareds cancel and they give me a y. And on the right side, just like the x's, I get an 11. And for my answer, I need to write it as a point, or points. The x-coordinate of the point is going to be 0. The y-coordinates of my points are going to be 11 and negative 11. So my y-intercepts are going to be 0, 11 and 0, negative 11. Let me do a few more problems and then I'll pause the video for a second. 7, 8, and 9 are, I think, the easiest problems to figure out the kind of symmetry from a graph. A graph has x-axis symmetry if a line through the x-axis cuts it into two equal pieces. A graph has y-axis symmetry if a line through the y-axis cuts it into two equal pieces. And a graph has origin symmetry if it looks the same right side up and upside down. And if I look at number 7, and if I duplicate the graph for number 7, so 7 looks like this. If I flip the graph upside down, it's going the opposite direction, so it doesn't have origin symmetry. It doesn't look the same right side up as upside down, so it doesn't have origin symmetry. A line drawn through the x-axis doesn't split it in half, so it doesn't have x-axis symmetry. But a line drawn through the y-axis cuts it into two equal halves. Because a line drawn through the y-axis cuts it in equal halves, we say it has y-axis symmetry, and that's the only symmetry it has. Similarly, for number 8, if I drew a picture of the graph for number 8, if I flip this over, the initial graph is opening up. When it's flipped over, it opens down. Since it doesn't face the same direction when it's flipped over, it doesn't have origin symmetry. A line drawn through the x-axis doesn't cut it in half, so it doesn't have x-axis symmetry. But the line, again, drawn through the y-axis cuts it into two equal halves. So this one also has to have y-axis symmetry. For problem 9, if I drew the graph on another sheet of paper, turn that sheet of paper over. When I turn the piece of paper over, the graph, instead of opening up to the right, opens up to the left, so it doesn't have origin symmetry. The line drawn through the y-axis doesn't cut it into equal halves, so it doesn't have y-axis symmetry. But a line drawn through the x-axis does cut it into equal halves, so it has x-axis symmetry. So this graph for number 9, I'm going to say it has x-axis symmetry. All right, so the next 3 problems ask us to find symmetry using algebra, and these are the trickier problems. So I'm going to take a break here for a second and come back and do that in a minute. All right, the next 3 problems are probably the most missed problems when I ask them on a test. They ask me to use basically, they ask me to determine the type of symmetry that the graph of an equation has, if it has any symmetry, and it should say, and perform the proper algebraic test to confirm it. And for these problems, when I did the video, I showed you how to find the symmetry first by sketching a graph and then doing the test. We also mentioned that usually if there's a y squared, usually we have symmetry to the x-axis. This would be the case if there's a y squared and not a y to the first power term. If there's an x squared, usually we have symmetry to the y-axis. That is, if there's an x squared term and not an x to the first power term. And if both the x and the y have odd exponents and there's not a constant term, we have symmetry to the origin. This is not 100% a guarantee, but it's pretty close. For our class, it'll be 100% guarantee. In general, it's probably not 100% guarantee. So if it has a y squared and no y to the first power term, if it has an x squared and no x to the first power term, and if it has both x and y exponents and no constant, that would be a number without a letter. So in each one of these cases, I can, by looking at the equation, if it fits these cases, predict the symmetry. And problem 10, when I look at it, I see a y squared term. I don't see a y to the first power term. That's good. I don't see it, so I think it probably has symmetry to the x-axis. I don't see an x squared term, so I don't think it has symmetry to the y-axis. And not both letters have odd exponents. The y has an even exponent, so it probably doesn't have origin symmetry. My guess is this is going to have symmetry to the x-axis, and the appropriate test to do is to replace the x with a negative x and solve for y. When we did these in the video, I sketched a graph first, and this is a hard one to sketch a graph. So if I want a graph, just to make sure my guess is correct, if I want to graph y squared equals x plus 3, I need to solve this equation for y by square rooting plus or minus square rooting. And that will give y equals plus or minus the square root of x plus 3. And on my calculator, I'm going to graph y1 equals the square root of x plus 3, and y2 equals the minus square root of x plus 3. I'll look at that graph. That graph should have symmetry to the x-axis. If it does have symmetry to the x-axis, then I'm really fairly certain the graph is really symmetric to the x-axis, and I'll do the appropriate algebraic test. The appropriate algebraic test to check for x-axis symmetry is to replace the y with negative y and solve for x. So let me go ahead and graph this. Clear, go y equals, clear, and then second square root of x plus 3, and then negative second square root of x plus 3. I don't know what window I used recently on my calculator, so I'm going to hit my zoom button and the standard key. And I get the two halves of the graph that is absolutely symmetric to the x-axis, because the line drawn through the x-axis would cut this into equal halves. So I know my answer to this is going to have x-axis symmetry, but I need to do the appropriate test to confirm the symmetry. And the appropriate test to confirm x-axis symmetry that you absolutely have to show on the test, if you actually can't spell that, appropriate test is to replace the y with negative y, and it has to simplify back to the original problem. So my test to confirm x-axis symmetry. I'll do right here below, and you need this on the test to get credit for this question. So I'm going to change the y in the initial problem, that's this y right there, to negative y, and I'm just going to do the algebra to simplify this. And all the symmetry tests, the algebra has to simplify back to the original problem. If the algebra doesn't simplify back to the original problem, it doesn't have that kind of symmetry. So negative y squared is the same as negative y times negative y. Negative y times negative y is positive y squared. Because this simplifies back to the original problem, I know that I have x-axis symmetry. So these three little lines right here, you're going to have to show on the test before you write an answer. The answer to problem 10 is the graph has x-axis symmetry. But if that's all you wrote is the graph has x-axis symmetry, you're going to lose most of the points because you'd have to do the appropriate test. When I look at problem 11, it has an x squared and not an x to the first power term. And when I see an x squared, usually I think symmetry to the y-axis. It doesn't have a y squared, so it probably doesn't have symmetry to the x-axis. And because the x has an even exponent, it probably doesn't have symmetry to the origin. So my guess for number 11 is it has symmetry to the y-axis because of the x squared in the problem. So that's kind of the first level of this. I glance at the problem. I suspect it has y-axis symmetry. And I'm going to get a second level of confirmation by sketching a graph. And in order to sketch a graph of this to make sure my guess seems reasonable, I need to solve this equation for y. This equation's a lot easier to solve for y than the last equation. I can minus x squared from both sides, and I have my choice of writing y equals minus x squared plus 6 or 6 minus x squared. They're both will graph exactly the same. For me, it's easier to enter 6 minus x squared than it is minus x squared plus 6, but it hardly matters. So I'm going to sketch a graph of this, and that graph should have symmetry to the y-axis. So I'm going to go y equals, clear out the two functions I entered for problem 10, and go 6 minus x squared. I think my window's going to be okay. I see a parabola that's kind of the vertex is on the y-axis. The y-axis really looks like it cuts the graph into two equal halves. So I'm really fairly confident that my graph has y-axis symmetry. Now I need to do the appropriate test to confirm that it has y-axis symmetry. And the appropriate test to confirm y-axis symmetry is to replace the x with negative x, and it has to simplify to the original problem. So for this problem right here, here's the appropriate test that's going to lead me to confirm that my guess is right and the graph isn't fooling me. I'm going to go negative x quantity squared plus y equal to 6, replacing the x with negative x. This will give me negative x times negative x plus y equal to 6. And negative x times negative x is positive x squared. That gives me, I don't know why I just put two plus signs. That gives me x squared plus y equal to 6. And so I've done the appropriate test, and now I can make an answer to problem 11. The answer for the kind of symmetry that the graph in problem 11 has is it has y-axis symmetry. Again, if you don't show this little boxed bit of work, then you're not going to get credit on the test. The last one of these problems that we have to work with the symmetry is problem 12. And when I look at my little rules, I don't see a y squared, so I don't think there's going to be x-axis symmetry. I don't see an x squared, I don't think there's going to be y-axis symmetry. But both x and y has an exponent of 1, x has an exponent of 3. Both x and y have odd exponents, and there isn't a term without a letter. There's no constant term. I think it has origin symmetry. So I suspect origin symmetry. I'm going to go ahead and graph this to see if my guess is making sense. It's real easy to graph this because it's solved for y. I don't need to do any preliminary algebra. So as I go to graph to get my guess confirmed, I'm going to graph y equals x cubed. I'm going to graph it, and that graph looks something like this. And for a graph to have origin symmetry, when I take my graph and I flip it over, it has to look exactly the same. The graph that I copied from my calculator and the graph of my calculator flipped over look exactly the same. So that probably means I have origin symmetry. And so I've got two reasons to think I have origin symmetry. First, both the x and the y have odd exponents. There's no constant term. Second, the graph looks the same upside down as right side up. Now I need to do the appropriate test to confirm the symmetry. And this is the hardest test. What I need to do is replace both the x with negative x and the y with negative y and simplify. Oh, gosh. So I'm going to take my original problem, and here's the appropriate test that you need to show on the test to get full credit. The appropriate test is going to go negative y equals negative x quantity cubed. This is going to be negative y equals negative x times negative x times negative x. And these are really negative 1x times negative 1x times negative 1x because negative x means negative 1x. I'm going to multiply the three negative 1's, and I'm going to multiply the three x's. Negative 1 times negative 1 times negative 1 is negative 1. X times x is x cubed. So this gives me negative y, which is really negative 1y, equals negative 1x cubed. And now I'm going to multiply both sides by a negative 1. When I do that, I multiply the two negative 1's, and I get positive 1y equals positive 1x cubed. I don't need to write those ones, so that's the same as y equal to x cubed. Since that's the same as the original problem, my appropriate test confirmed my guess that I have origin symmetry, and the answer I'm going to write for number 12 is we have origin symmetry. All right, for me, that's the worst part of this chapter. So the next two problems want me to find intercepts and sketch a graph, and it says it'll be enough to label 2 points. We need to connect those 2 points with a line because this graph is going to be a line. So I'm going to find the x-intercept by letting y equal to 0. I'm going to find the y-intercept by letting x equal to 0. And then I'm going to, for each of those, it's going to be a point, and then I'm going to graph the points and make a line through them. So for the x-intercept, I'm going to go 2x plus 3 times 0 equals to 12. This will simplify to 2x equal to 12. And then I'll divide both sides by 2 and get x equal to 6. Part of my answer is going to be the x-intercept is the point 60. And then for the y-intercept, I'll let x equal to 0. So I'm going to go 2 times 0 plus 3y equals to 12. This zeroes out. This simplifies to 3y equals to 12. And then I'll divide both sides by 3 and get y equal to 4. So for my y-intercept, the y-coordinate is 4, the x-coordinate is 0. So I'm going to get the point 0, 4. And then, so that's finding the x and the y-intercepts. Now I'm going to do then sketch a graph. Easy enough to sketch this graph. I didn't even make graph paper for it. I'm going to plot the point 0, 4, which is the y-intercept, and the point 1, 2, 3, 4, 5, 6, 0, which is the x-intercept, and connect them with a line. If you just plot the points and don't connect them with a line, that's not enough. So that's everything for problem 13. 14 and 15 have the same instructions, find the x and the y-intercepts and sketch a graph, so I'll do those the same way. 14 has ugly fractions, so I'm going to find the x-intercept by letting y equal to 0. I'm going to find the y-intercept by letting x equal to 0. So for the x-intercept, I'm going to go 1/2 x minus 2/3 times 0 equals to 5. That will simplify to 1/2 x equals to 5. And at this point, I can multiply both sides by 2, or I could divide both sides by 1/2. Most students really fumble with these fractions, so I'm going to do the fractions as easily as I can. I'll do them on my calculator. Dividing the left side by 1/2, you're left with the x. On the right side, to do 5 divided by 1/2, I can just go 5 divided by parentheses 1 divided by 2 for 1/2, and that's going to give me 10. The nicer way to solve this problem would have been to multiply both sides by 2. When you have 1/2 x equal to 5, if you multiply both sides by 2, on the left side the 2's would cancel, on the right side you'd get the 10. So part of my answer to problem 14 is the x-intercept is the point 10, 0. I'll do the same thing for the y-intercept. Put in 0 for x. So I'm going to go 1/2 times 0 minus 2/3 y equal to 5. This gives me minus 2/3 y equal to 5, and I'll be lazy. I can multiply both sides by negative 3/2, or I could divide both sides by negative 2/3. If I'm going to divide both sides by negative 2/3, I'm probably going to exploit my calculator, and this is going to be a decimal that I'm going to make into a fraction. On the left-hand side, I cancel out the minus 2/3. I'm left with a y. On the right-hand side, I go 5 divided by parentheses negative 2 divided by 3. It gives me negative 7.5. That's going to help when I graph it. I'm going to do a fraction answer. To get negative 7.5 to turn into a fraction, you hit the math button and then enter twice. So for my y-intercept, I'm going to say it's the point 0, negative 15 over 2. And when I go to graph this, the x-intercept's easy enough to plot. I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plot 10 on the x-axis. And for the y-intercept, I'm plotting negative 7.5 on the y-axis. I'm going to call it negative 15/2. So negative 1, 2, 3, 4, 5, 6, 7, 8. And my negative 7.5 is right there. I'm going to call that point the point 0, negative 15/2. Prefer decimals, fractions to decimals, and now I'm just going to connect those 2 points with a line. All right, one more of these intercept problems. So for 15, x-intercept, I let y be 0. Y-intercept, I let x equal to 0. So for the x-intercept, I'm going to go 2/3 x plus 2 times 0 equals negative 4. That will give me 2/3 x equals negative 4. I could multiply both sides by 3/2, or I can divide both sides by 2/3. Students really fumble with these fractions, so I'm just going to do the calculator non-thinking approach. Cancel the 2/3 on the left-hand side. On the right-hand side, I need to go -4, -4, divided by parentheses 2 divided by 3, and it gives me -6. So for part of my answer, the X intercept is going to be the point -6, 0. The y-intercept is going to be easy. For the y-intercept, I'm going to plug in 0 for x. I'm going to go 2/3 times 0 plus 2y equals -4. This is going to simplify to 2y equal to -4. And then I divide both sides by 2 and get y equal to -2. So my y-intercept is the point 0, -2. Now I'll just sketch a graph. I'm going to plot -6 on the x-axis. Call that the point -6, 0. Plot -2 on the y-axis. Call that the point 0, -2. And finish up the graph. The graph's a line, so I connect the 2 points with a line. I usually throw arrows at the end of my line, but it's not a deal if you don't put the arrows there. All right. 16 through 19, finding equations of lines. The first couple ones are easy because they give me a slope and a point, and to find an equation of a line if you have a slope and a point, you just want to use the formula y minus y1 equals m times x minus x1. In this problem, for m, I'm going to plug in 3 because that's the slope. For x1, I'm going to plug in 5 because that's the x-coordinate of the first point. And for y1, I'm going to plug in 1 because that's the y-coordinate of the first and the only point. So I'm going to go y minus 1 equals 3 times x minus 5. This will give me y minus 1 equals, clear the parentheses, 3 times x and 3 times minus 5. So you get y minus 1 equals 3x minus 15. Basically, at my answer, I just have to add 1 to both sides. On the left-hand side, the ones cancel. On the right-hand side, the numbers have opposite signs, so I subtract and take the sign of the larger and get y equals 3x minus 14. For problem 17, I'm also going to use the y minus y1 equals m times x minus x1 formula. For m, I'm going to plug in 2/3. For x1, I'm going to plug in -6. And for y1, I'm going to plug in 2. I'm going to go y minus 2 equals 2/3 times x minus a -6. I have that double negative. I'm going to put that second negative in a parentheses. This is going to give me y minus 2 equals 2/3 times x plus 6. And then on the right-hand side, I have to go 2/3 times x, which I'm going to write as 2/3 x. I also have to do 2/3 times 6. And to do 2/3 times 6, if I want to, I could just multiply the 2 and the 6. That will give me 12 over 3, and that's going to give me 4. I also could multiply 2/3 times 6 on my calculator. I could have done parentheses 2 divided by 3 times 6, and that's going to give me 4 as well. I could have canceled the 6 and the 3 and got 2 times 2. However you want to multiply that fraction, you need to be able to multiply it somehow, whether it's using your calculator or doing it by hand, using some method. Finish this up by solving for y by adding 2 to both sides. I'm going to get my answer of y equals 2/3 x plus 6. All right, so in problem 18, I give you the x1 and y1. That's the point x1 equal to 2, y1 equal to 1. I don't give you the slope, but I tell you my line that I'm trying to find is parallel to the line y equals 2x plus 6. And parallel lines have exactly the same slope. This line, because it's solved for y, the number in front of the x2 is its slope. My line has to have the same slope as this line because it's parallel. So for my work, I'm going to use the slope of the given line as the slope of my line, which is going to be 2. So I'm going to use the y minus y1 formula equals m times x minus x1 formula. In for the y1, I'm going to plug 1. In for the x1, I'm going to plug 2. And in for the m, I'm also going to plug 2. I'm going to go y minus 1 equals 2 times x minus 2. I'm going to clear the parentheses on the right-hand side by going 2 times x and 2 times minus 2. That will give me y minus 1 equals 2x minus 4. And then I'm going to add 1 to both sides and get my answer of y equals 2x minus 3. I think I'll do one more and then I'll make a part 2 to this video, which is kind of the circle-y part and the word problems. So 19, I have the x1 and the y1, that's the point. I'm told I'm finding an equation of a parallel line. Just like in 18, the slope of the given line is the number in front of the x. The slope of the given line is 4/9. Because my line is parallel, I'm going to steal that slope because my slope is going to be the same. Parallel lines have equal slopes. So I'm going to use the formula y minus y1 equals m times x minus x1. And for y1, I'm going to plug in -1. And for m, I'm going to plug in 4/9. And then for x1, I'm going to plug in 3. I'm going to go y minus -1 equals 4/9 times x minus 3. Double negative on the right side, I'm going to make a y plus 1. Clearing the parentheses, the first multiplication is 4/9 times x, which I write 4/9x. The second multiplication is 4/9 times -3. If I want to, I could multiply the 4 and the -3 and get -12 and leave the 9 in the denominator and then reduce that by 3. -12 divided by 3 is -4. 9 divided by 3 is 3. And I'm going to get -4/3. I could have just done this multiplication of parentheses 4 divided by 9 times -3 on my calculator. And if I do that, I have to go math, enter, enter to get it into the fraction form. Lastly, I just have to -1 from both sides. On the left-hand side, I get a y. On the right-hand side, I get 4/9x. And I have to figure out what -4/3 minus 1 is. If you want to do that on your calculator, just go -4 divided by 3 minus 1 equals math, enter, enter. And that will give me -7/3. That's going to be my answer. I have like 20 seconds to do this by hand. To do this by hand, you'd have to go -4/3 minus 1/1. Multiply the 1/1 by 3/3. It'll give me -4/3 minus 3/3, which is -7/3. So I'm going to pause the video. I'm going to do a part 2 for problems for the rest of the review.